In this video, we'll do two examples of sharpening of edges in images. Our first example will be to reproduce the figures shown in figure 4.21 on page 141 using the method described in example 4.9b on page 165. First, we'll open a two-dimensional form and load an image. We right-click on the graph box there and click Load Image. House. Let's get the large size. Now we'll do a wavelet transform. Daub 4, one level. And now we'll process that transform. This is the formula that's given on page 165. G2 standing for graph 2 plus 2 times G2 times this formula here, which will give a value of 1 exactly when x is greater than or equal to 0 or y is greater than or equal to 0. In other words, just the fluctuation subimages are going to be multiplied and added to G2, so we're going to get 3 times the fluctuation subimages, and then this trend subimage is left exactly the way it is. Okay, we'll click Plot, and we see we've amplified the fluctuation subimages, left the trend subimage alone. Now we'll inverse transform. That'll be graph number 3. Now that we've done that processing, I'll get rid of the process transform here. And now we'll quantize the processed image. That'll be now graph number 3, since we removed one graph, and there's the processed image finished by quantizing. And you can see it's much sharper edges than the original here. For instance, the window divider, which is barely visible there, now is clearly visible. The fencing is very sharply defined, where here it's quite blurry. It does overemphasize some of the background sky, some artifacts there, but overall it's a much improved, sharper image. Now let's look at one more example, not shown in the book, but it's a nice example. Let's load a image of a fingerprint. Fingerprint 1 here, go to large size. We'll do a wavelet transform. This time we'll do Daub 9.7 and 2 levels. And now we'll process that transform. This time we're going to process the 2 fluctuation levels that are shown here. So we're going to use this formula, G2 plus 1.5 G2 times 1 minus x less than c times y greater than c. What that does is, since c is minus 0.25, that will give a value of 1 exactly when we're in the fluctuation regions. So we're going to get 2.5 times the fluctuation subimages in the transform and leave the trend part of the transform alone. So let's click Plot. And you can see we amplified in here a lot. They're very small fluctuation values out here, so they're hard to see a difference there. But there is. Now we'll inverse wavelet transform. That's graph number 3 now. And that, which still needs to be quantized to get a nice picture there. So we'll delete the transform that we did. Now there's that graph, which we will now quantize. It's graph number 3. And you can see it's a changed image. To really appreciate it, we need to zoom in on a region of the fingerprint. Let's zoom in. I'll just click someplace in the center here and zoom in a couple times. And that's the original, and you can see it's a little bit blurry. There's the processed transform. Much enhanced. The little dots here, the sweat pores, are much easier to identify. They're much more clearly defined. So here we've shown how we've used the Wavelet transform to very significantly enhance the edges, the sharpness of two different images. That concludes this video. Thank you for watching.